Hey guys, Mr. Zigner here. Today we're going to be looking at comparing linear and nonlinear functions. Now, if you take a look at my image I have here, these are the linear and these are the nonlinear functions. And you might already be able to guess what the difference is. Do you see it? Okay, so let's just jump into this. The graph of a linear function shows a constant rate of change. So linear, by definition, means you end up with a straight line. So a straight line graph. A nonlinear function does not have a constant rate of change, so its graph ends up not being a line. So I grabbed a picture of a Wawa here, Wawa gas station. Thought we'd sort of try to explain this whole constant rate of change thing using Wawa. I'll use red because Wawa uses red. So if I go to the gas station, let's just say gas is, well, I don't know, say $2.50 per gallon. So if I buy 1 gallon, so I'll make the number of gallons I buy be my X here, that would cost me $2.50. If I bought 2 gallons of gas, well, 2 times 250 would be $5. If I bought 3 gallons, that would be $7.50. Do you see what I'm doing to get these bottom numbers here in the Y? If I bought 4 gallons, do you know what that would be? $10. Do you see the constant right here, constant rate of change? So as my X values, which were the gallons of gas I was going to buy, are increasing by 1, the price for the gas, that would be my Y value, is increasing by, do you see it? $2.50. So that's what I'm talking about when we say a constant rate of change. If the X's are increasing by a consistent amount, then the Y's have to increase or decrease by their own consistent amount. Okay, let's keep going. All right, so here's some examples that the book created for us. Do we have linear or nonlinear functions? Well, you can see there's one of each, but let's walk through them. Here in A is does have a constant rate of change, so it is linear. Our X's are increasing by 3. Our Y's, 40 to 32, down to 24, down to 16, they're decreasing by 8. So as long as your X's have a consistent rate of change and the Y's have their own consistent rate of change, doesn't matter if it's plus or minus, as long as it's consistent, then you do have a constant rate of change. And then the function's considered linear. If we made a graph out of this, you'd get a straight line. Over here, well, our X's look good. They're increasing by 2, but now from 2 to 11, that's an increase of 9. From 11 to 33, that's an increase of 22. From 33 to 88, that's an increase of 55. So nope. See, as X increases by 2, the Y was increasing by different amounts. So the rate of change is not constant. So the function is nonlinear. Okay, hopefully that makes sense. Here's some examples for us to look at now with a graph. Do we have linear or nonlinear functions? Well, this part I think is going to be pretty easy. That pretty obviously is not a straight line. So since we do not have a straight line, we have a nonlinear function. So there, that one's nonlinear. Here, do you see the line? It's going horizontally here. So that's straight as can be. So since that is a line, it is a linear function. There we go. That's all there is to that when you're looking at a graph. Okay, here's our first few to try for ourselves. Do we have linear or nonlinear functions? All right. So in the table, remember what you do? We find out if our X's and our Y's have a constant rate of change. What are our X's doing here? 0 to 7 to 14 to 21. Well, they keep increasing by 7. What's happening with the Y's? 25, 20, 15, 10. Well, that looks like it's decreasing by 5 each time. So yeah, this is linear. We have a consistent rate of change. So the explanation would be your X's are increasing by 7, the Y's are decreasing by 5. There is a constant rate of change in the table. All right, let's try this one. Change colors. So now we have 2, 4, 6, 8. Well, that's clearly an increase of 2 each time. 8, 4, 0, -4. Oh, well, that's going down by 4 each time. Once again, we have our consistent rate of change, so we have another linear function. Again, explaining We have a consistent rate of change in our table. The x's are increasing by 2, and the y's are decreasing by 4. There's a wonderful explanation. And now here, number 3. Well, come on. That's definitely not a straight line. That looks like either a little mountain someone drew or an upside down letter V. So this is nonlinear. It has to be a perfectly straight line. No curves, no bends, nothing else. Just one straight line. It doesn't matter what angle or horizontal. It just has to be a straight line, and that clearly is not. Okay, another example. Which of these equations is nonlinear? Okay, well, if you're talking about equations, you have to be able to rewrite the equation in one of the linear formats, and probably the easiest one to work with is slope-intercept. Now, in my other videos, I talk about slope-intercept forms, so look one of those up and you'll get a little background on how slope-intercept works. But the m is my slope, the b is my y-intercept. And let's see, if we can rewrite these equations in slope-intercept, then they're going to be a nice straight linear function. So let's take this right here. Well, that would, since there's no x after it, that must be the y-intercept. So I could rewrite this one as y equals 0x plus 4.7. There we go. So there's slope-intercept. Has a slope of 0 and a y-intercept of 4.7. So this one is definitely linear. So it's not nonlinear. This one's a linear function. How about this one? Y equals pi x. Y equals pi x. What about the plus b? Well, there is nothing here, so I could just put in plus 0. So once again, we have y equals mx plus b. So it's not this one. This one's perfectly linear also. Here they're trying to trick us, but let's use distributive property, and we'll turn this one into, again, y equals mx plus b. So that would be y equals 4 times x would be 4x. And now 4 times 1 would be 4. And we have a minus sign in the middle. And there it is, y equals mx plus b, or in this case, y equals 4x minus 4. It's not this one. Here it is right here. And here's the explanation down here. You cannot rewrite the equation y equals 4 divided by x in slope-intercept form. So it is nonlinear. There we go. So the short answer to this is, can you rewrite it in slope-intercept form? Or is it already in slope-intercept form? Well, if that's the case, it's linear. If you can't, in this case, they're using division instead of multiplication like we want right here, 4x, not 4 divided by x. Then you would end up with a nonlinear function. If we tried to make a graph out of this, it would not be a straight line. So now I've highlighted the ones I'm going to do here. For my students, I'm not too worried about the graph because I'd rather us figure it out without the graph. But if you want to print the worksheet out and graph it also, that's perfectly fine. All right, here we go. So is the graph linear or nonlinear? Well, all right, I'll plot these points. So -1, -1 would go right here. 0, 1 would be right here. 1, 3, so 1 to the right, up 3. 2, 5. 1, 2, 1, 2, 3, 4. Ha! They didn't give me enough space. I guess I could have started all over and counted by a different amount. I'm just going to guess here, which I normally don't like doing, but I don't want to stop the video and restart this whole problem. As you can see, we have a straight line. And let's check instead of the graph, though, do I have a consistent rate of change? Well, -1 to 0 to 1 to 2. Well, these x's are increasing by 1. Do I have a consistent rate of change down here in the y's? -1 to 1, well, that's an increase of 2. 1 plus 2 is 3, and 3 plus 2 is 5. So yeah, my y's are increasing by 2. So this is definitely linear. Even if I wouldn't have made this graph, I can see that I have a constant rate of change. My x's are increasing by 1, my y's are increasing by 2. So that's definitely linear. Okay, does the graph represent a linear or nonlinear? Well, I gave myself an easy one. This one actually looks like another one I did. So this is definitely nonlinear. It has to be a straight line. Little hint there for my students. And I'm skipping number 5. And here we go, number 2 on this one. Graph the data in the table. Again, I think we're going to skip the graph. We can figure it out without the graph. Decide whether the graph is linear or nonlinear. So that's what we're looking for. All right, well, let's just check for that constant rate of change. So 1, 2, 3, 4. Well, that's increasing by 1. What are my y's doing? 4, 6, 9, 13. 4 to 6, that's an increase of 2. 6 to 9, that's an increase of 3. And 9 to 13, 9, 10, 11, 12, 13, that's an increase of 4. No, we do not have a consistent, constant rate of change. So it's still a function. It's just non-linear. And again, if you would get a piece of graph paper out and graph that, you would not have a straight line. Okay. I did number 4, or I'm going to do number 4 rather. Okay, here's our graph. Does our graph represent linear or nonlinear? Hey, I finally got a nice straight line. There we go. So this one is linear. See, that's all there is to it. The explanation would be the graph is a straight line. And that's it. Number 6. Once again, do we have, well, those directions are, linear or nonlinear function explained? Okay. So what are my x's doing? 4 plus 3 is 7. 7 plus 3 is 10. And 10 plus 3 is 13. So my x's are increasing by 3. Negative 2 to 0 increases 2. Plus 2 is 2. Plus 2 is 4. Yeah, we have a constant rate of change in our x's and our y's. So this is linear. Both of them have to have the x's and the y's both have to have their amount they're either increasing or decreasing by. This one's going to be for my students, but I'm going to give a little hint here. Again, do we have a consistent rate of change? So here you can see your radius. Check those numbers out. Is that consistent? Okay. And now look at the area. Is this a constant rate of change? Is it increasing by a fixed amount each time? And I think, I'm not going to say it, but pretty clearly you should be able to tell whether or not that's a constant rate of change. Is it increasing by the same amount each time? But finally, here's one more for me to look at. We have a table here of the cost of cereal. So what is a missing y value? Okay, so this one right here, that makes the table represent a nonlinear function. Oh, okay. So what they want here is what number could you put here and it wouldn't end up helping make this into a straight line? Well, that would be anything that wouldn't be a constant rate of change. So let me see here. These are increasing by 4. This from here to here increases by 1. So whatever number I put here, as long as it's not just 1 less than 2.5, we're okay. So I could put anything I want here. How about negative 37? Well, you know what? Let's not make it negative because we're talking about cereal. But let's make it positive 37. There we go. If I put a 37 here and graphed these 3 points on a piece of graph paper, it would not be a straight line. There we go. So basically any number, then the right answer would make this nonlinear. Okay, part B. What is the missing y value that makes the table represent a linear function? Okay, so this is the one that has to be the exact constant rate of change. So if this is increasing by 4 in my x's and my y's look like they're supposed to be increasing by 1, well, to backtrack it back to this first number, I guess I would have to subtract 1. So 2.5 minus 1, well, that's 1.5. There we go. So 1.5 would be, or I guess this is money, so $1.50 would be the amount for 8 ounces. Okay, so write a linear function that represents the cost of X ounces of cereal. Oh, so now they want us to make the equation for this situation. All righty. So, well, the first thing we need to know is our slope for that. So that's our m value. What's our change in y over change in x? Oh, I'm sorry, I did that backwards. I did x over y. So change in y is 1. They're increasing by 1. Our change in x was 4. Okay, 1/4. But wait a minute, this is about money. Remember, it's about dollars, how much the cereal costs. So let's convert this into money. So 1/4 of $1, I'm sure most of you would know that, would be 25 cents. Okay, there we go. So it looks like it's 25 cents per ounce. Okay, alrighty, but it may not be that simple. Let me set up the equation so far. But so far we have y equals 0.25 x. Oh, and let me further explain. We're trying to set this up into slope-intercept. So y equals mx plus b. But see, I don't have my plus b yet. I need to figure what that is. Now, it might be 0, in which case I'll just leave it off, but I don't think it's 0. It doesn't feel like it's going to be 0. Now, you might wonder, well, how do you get from here to knowing what this b value is? And here's what you do. You just take one of the amounts in your table. Now, we already said that this was 0.25. Oh, no, I'm sorry. No, that's not correct. We already figured it out over here. It was 1.5. My bad. There we go. Sorry for the confusion there. We already figured out this was 1.5. Now, the 8 is the x, the y is the 1.5. So here's a neat little trick you can do. You just take one of the sets of numbers in the table, and you just replace the x and the y in the equation that you have so far. Solve, okay? And then we'll end up with this b value. All right, so let's put those in. So the y is this 1.5. Check this little method out. Bring me down my 0.25. X. Now the x was this 8 plus b. Okay, so 1.5 equals, now what's 1/4 of 8? Well, that'd be 2. Now, to make the video a little bit shorter, I'm going to not show the work for that, but if you sit down with a calculator or pen and paper, multiply 8 by 0.25, or just think 1/4 of 8, you will get 2 plus b. All right, so I need this b by itself. So right now I'm adding 2. The opposite of adding 2 is subtracting 2. So let's subtract 2 from both sides of the equation. The reason I do that is to get this letter b by itself, and I just did that. So b equals, well, what's 1.5 minus 2? Well, that's negative 0.5. Okay, so I've got my b value. Up here I have my m value, and I can put all that together and get my equation. So here it is. So in y equals mx plus b format, this is called slope-intercept, you would have y equals 0.25 x. Now this is negative 0.5, so I'm just going to write that as minus 0.5. And there we go. That would be the equation for this situation with the price for cereal. Oh, and that brings us to the end of our time. So thanks for joining me for linear and nonlinear functions. You can see my website on the screen there. Hey, if you enjoyed the video, again, please like, comment, subscribe before you head out. Thanks, guys, and we'll see you next time. Bye-bye.